Okay, welcome back. Another attempt to work on my earthquake model. I don't know if I call it earthquake prediction model. My earthquake correlation model that shows the likelihood of, or that shows information correlating earthquakes around the world, and hopefully can eventually be used for earthquake prediction, but I wouldn't put it out there just yet. But what I'm especially looking at is how earthquakes tend to align along geodesics on the Earth, which are grade arcs around the Earth, which are arcs that bisect two equal halves for a spherical approximation. And I'm looking at geodesics plus or minus 3 days formed from pairs of earthquakes that are within 10 to 170 degrees of each other, no closer than 10 and no farther than 170 degrees. And once I form those geodesics, then I compare them to our quake at the center of our 3-day time interval. And I look to see if it is within 0.1 degrees. That's our current model parameters. And if it is, then I highlight it on here. So here we have this Caribbean quake within 0.1 degrees, and it's touching 9 other arcs around the world, 9 other geodesics around the world, formed by 2 or more pairs of quakes around the world. So each geodesic is going to run through 2 or more points, which is kind of coincidental. Like here, Caribbean, Puerto Rico, right? Through this, looks like California, and through these Indonesia, Papua New Guinea quakes around the whole world. Same thing, Caribbean, through Panama here, and then back the other way through Turkey here. Isn't that weird? We have like 3 quakes in a row, perpendicular directions, and then never mind the Aleutian Islands here, tons there, all point to the Puerto Rico quake, or same with East Asia here. So we have multiple geodesics all pointing at this exact same location right as it erupts, right? So that's what the model is. I'm adding to it some extra information, like I've got the planets here. The yellow concentric rings is where the sun is, just past India. The gray ones is where the moon is in the Pacific, and I have their antipodes, right? So go back 1 quake to Texas here, right underneath the opposite side of the sun when it struck. Isn't that weird? And this quake, Texas quake, has 155 geodesics through it, but a lot of that's probably duplicates. I don't think I'm filtering at the moment like duplicate pairs of, like if a whole bunch of Aleutian Islands and a whole bunch of whatever Idaho strike, that'll make a whole bunch of geodesics that all touched here. So I'm working on the filtering of data. You know, if anyone here has some background in radon transforms or Hoyt transforms on spherical surfaces, then give me a shout out and help me with this model. But yeah, a whole bunch of geodesics are going through this one, and I'm trying hardest to discount. I don't just want random lines, branching out everywhere, but each of these should be going through 1, 2 at least. Maybe there's 3 in there. Other quakes, 1, 2, 3, 4 other quakes. Maybe I should add like here, number of touching arcs. I should have a drop down or something so I can check for each arc how many other points that one is touching. So I'll get to that in the future, but I really wanted to show off the new planet stuff and how it lines up with a few quakes around the world. And there's our Turkey quakes. Is it Greece, Turkey? That one looks like Greece. Yep, Greece, Turkey, quakes. Interesting, that's almost quite antipode of the moon. And I think we had one here that was right around the sun. Let me go back to, maybe it's that one. Yeah, okay. So this is another big one that I saw a lot of geodesics going through. Yeah, 87. And once again, each one of these goes through 2 or more other quakes that form a geodesic that gets within 0.1 degrees of this. And look at that, was right in line with the moon when it struck. So I'm adding planet stuff to this. I don't think I'm going to go through all the quakes like I did last time, but I just want to show off the new stuff I made. I added all the planets. I've got their concentric rings of certain fixed angles, right, at different angles. And if anyone knows the geometry index predictor stuff that's out there, I forget the name of the organization that's really pushing this and getting attention. I think this is kind of the idea that they have. I don't know if they're looking at just angles planets make with the Earth, or if they are looking at positions on Earth, the angles that planets make. Like this, that's what this is a map of. For every point on Earth, you can see what angles are made with what planets, right? So I'm throwing that into the mix. I don't know if I think if this model has much weight. Maybe it does, maybe it doesn't, but it's just good to have the extra information. Later, I'll throw in the gravity probe B, the GRACE maps. Later, I'll throw in tidal maps and gravitation maps of the planets. I already had that stuff in my 10-year-old solar system model that used to sit on my webpage. That is now down because I'm too poor to maintain it. Maybe I'll bring it back. The source code is still on GitHub. If anyone wants to look at it, it's there for you to look at. And let me just show off what else have I added, not just the planet stuff, which can get tedious. Let me just look at the moon stuff. That's all I care about. The sun and the moon are the most significant gravitational and tidal force influences on Earth. But I also added some more transform stuff. There's the familiar latitude, but now you can properly scroll the longitude and stuff like that. Azimuthal, we can put our quake at the center of the world, flat Earth style. If I can adjust the parameters right. There we go. There's our flat Earth quake at the center of the world, and our sun and our moon relative to our flat Earth model. And there's all our geodesics. Of course, if it was perfectly centered, the geodesics would all be straight lines to the horizon, which maybe I'll add a feature for centering on the quakes in the future. There's a lot of stuff I can add to this, but we'll see where things go. So thank you very much for tuning in, and I'll catch you guys next time.